Hi future scientists, I am Atom. Let us explore the pivotal roles played by Dmitry Mendeleev and Henry Moseley in shaping the periodic table, uncover the properties of the element families, and examine the individual elements within each family. Dmitry Mendeleev, 1834 to 1907, was a renowned Russian chemist who discovered the periodic table in 1869. He wrote the atomic weights and properties of the 63 elements known at that time and arranged them in groups that revealed periodic trends among the elements. He left gaps in his table for elements that had not yet been discovered and predicted their properties based on the patterns he observed. For example, here is Mendeleev's prediction for Eka aluminum or gallium from 1871. Atomic mass 68 AMU, density 5.9 gram per cubic centimeter. Gallium was discovered in 1875 with an atomic mass of 69.723 AMU and density 5.93 gram per cubic centimeter. Here is Mendeleev's prediction for Eka boron or scandium from 1871. Atomic mass 44 AMU. Scandium was discovered in 1879 with an atomic mass of 44.956 AMU. Here is Mendeleev's prediction for Eka silicon or germanium from 1871. Atomic mass 72 AMU, density 5.5 gram per cubic centimeter. Germanium was discovered in 1886 with atomic mass 72.63 AMU and density 5.35 gram per cubic centimeter. Here is Mendeleev's prediction for Eka manganese or technetium from 1871. Atomic mass 100 AMU. Technetium was discovered in 1937 with atomic mass 98.9 AMU. However, Mendeleev's periodic table had its limitations. For instance, the atomic mass of tellurium, 127.6 AMU, is higher than that of iodine, 126.9 AMU. But iodine had to be placed after tellurium to align with the chemical properties in their groups. Also, Mendeleev's table could not account for isotopes, which are atoms of the same element with same chemical properties but different masses. This is because Mendeleev arranged elements based on their atomic masses. Nevertheless, Mendeleev's periodic table laid the foundation for modern chemistry and revolutionized the way scientists understand the elements and their properties. Despite not receiving a Nobel Prize, Mendeleev earned the great honor of having an element named after him, which is element 101, Mendeleevia. How were the discrepancies in the periodic table resolved? Who resolved them? Henry Moseley, 1887 to 1915, was a British scientist who conducted experiments in 1913 to find a more fundamental basis for organizing the elements in the periodic table beyond just their atomic masses. In his experiments, Moseley bombarded different elements with high-energy electrons, a process known as X-ray spectroscopy. Through this, he observed that each element emitted a unique X-ray spectrum whose energy increased linearly with a steady increase in the strength of the positive charge in the atom's nucleus. Moseley's groundbreaking work demonstrated that the amount of positive charge in an atom's nucleus, which is the element's atomic number, is a more fundamental property than the atomic mass. Essentially, he established that an element's identity is determined by its unique number of protons or its atomic number. Therefore, it was more logical to arrange the elements by their atomic numbers rather than their atomic masses. This reorganization of the periodic table led to a more accurate arrangement of the elements that addressed many of the discrepancies that were present in Mendeleev's periodic table. Moseley's promising scientific career was tragically cut short when he enlisted in the British Army during World War I. He was killed by a sniper's bullet on August 10, 1915 in Gallipoli in Turkey, and he was only 27. After Mosley's tragic death, many countries decided not to bring great scientific minds to the war front, but instead have them do cutting-edge research to serve their country. Despite Mosley's nomination for the Nobel Prize in 1915, with the awards scheduled for 1916 for his work in reorganizing the periodic table, he was killed before the Nobel Committee could consider his nomination. No Nobel Prize was given for physics in 1916. Nevertheless, Mosley's groundbreaking work, which laid the foundation for the modern understanding of the periodic table, firmly established him as one of the most influential figures in the history of science. How is the periodic table organized? It's organized as element families. Hydrogen, its properties and uses. Hydrogen does not fit perfectly into any specific family, and it is placed above the family 1 metals because it is one valence electron similar to the family 1 metals. It is the lightest of all atoms, and it is the most abundant element in the universe. Hydrogen exists as a diatomic molecule, H2. Hydrogen is a highly flammable gas. It is essential in the formation of water, acids, and many organic compounds. Hydrogen is used in fuel cells to power vehicles. Liquid hydrogen is used as rocket fuel. What are the family 1 metals, their properties and uses? Family 1 metals are called the alkali metals because as they react with water, they form hydroxide ions, resulting in the formation of alkaline solutions. For example, when sodium reacts with water, it produces sodium hydroxide, which is a basic or alkaline solution, hydrogen gas, and heat energy. 2Na plus 2H2O gives 2NaOH plus H2 plus heat energy. Because of their high reactivity with water, the alkali metals are stored in mineral oil. The alkali metals are lithium, Li, sodium, Na, potassium, K, rubidium, Rb, cesium, Cs, and francium, Fr. They have one valence electron, as you can see in these electron configurations, and they tend to lose this electron to form a 1 plus ion in chemical bonds. Alkali metals are the most reactive metals, and their reactivity increases down the group as the atomic size increases. This family has low electronegativity, which is the element's ability to attract electrons. And francium has the lowest electronegativity of all elements. Alkali metals are soft and can be cut with a knife. Lithium. Lithium is used in rechargeable lithium-ion batteries. Sodium. Sodium is present in table salt or sodium chloride. Potassium. Bananas are a well-known food source of potassium. Also potatoes, sweet potatoes, spinach, avocados, and tomatoes. Rubidium is used in photocells, which are light sensors. Cesium is used in atomic clocks. Francium is extremely rare and highly radioactive. Its most stable isotope, francium-223, has a half-life of only about 22 minutes. It was discovered by Marguerite Perry, 1909 to 1975, a French scientist. What are the family 2 metals, their properties and uses? Family 2 is the alkaline earth metals. Historically, the term earth metals referred to oxides of metals which were often found in the Earth's crust. Alkaline refers to the basic or alkaline nature of the hydroxides formed when these metals react with water. For example, when magnesium reacts with water, it produces magnesium hydroxide, which is an alkaline solution. Mg plus 2H2O gives MgOH2 plus H2 plus heat energy. The alkaline earth metals are beryllium, Be, magnesium, Mg, calcium, Ca, strontium Sr, barium Ba, and radium Ra. They have 2 valence electrons and they lose these electrons to form 2 plus ions in chemical bonds. Beryllium is used in the space shuttle because it's light and strong. Emeralds contain the mineral beryl, beryllium aluminum silicate. Magnesium is used for airplane parts and car bodies. Did you know the chlorophyll molecule contains a magnesium atom? Calcium is needed for strong bones and teeth. Strontium is used to produce red color in pyrotechnics. Barium is used in medicine. Barium sulfate for medical imaging and fireworks, barium nitrate for the green color. Radium was discovered by Marie Curie, 1867 to 1934. It is extremely rare and radioactive, but has historical significance in radioluminescent paints and nuclear science. What are the family 13 elements, their properties and uses? Family 13 is the boron family. The elements in this group are boron, B, aluminum, Al, gallium, Ga, indium, In, and thallium, Tl. These elements have 3 valence electrons. They tend to lose 3 electrons and become 3 plus ions in chemical bonds, except for boron, which tends to share 3 electrons. Boron is a metalloid. Properties in between a metal and a nonmetal. Boron is used in the production of borosilicate glass because of its capacity to withstand thermal shock. This specialized glass is used in the manufacturing of laboratory and kitchen glassware. Borax, which contains boron, is sometimes used as a slime activator. Aluminum is a lightweight, corrosion-resistant metal used in aerospace and packaging. Rubies and sapphires contain aluminum oxide. Gallium is a metal. It is used in high-temperature thermometers. Gallium arsenide is present in the solar cells of the Mars rovers. Indium, a metal, is used to create indium tin oxide, ITO, a transparent conductive material used in touch screens. Thallium is a highly toxic metal. Thallium compounds were once used in rat poisons and insecticides, but have been largely phased out due to their toxicity. What are the family 14 elements, their properties and uses? Family 14 is the carbon family. The elements are carbon, C, silicon, Si, germanium, Ge, tin, Sn, and lead, Pb. They all have 4 valence electrons. They tend to share their 4 electrons in a chemical bond. Carbon is a nonmetal. It is the basis of life and is found in all living organisms. Its 4 main allotropes are graphite, diamond, graphene, and buckyball. Organic chemistry is a branch of chemistry dedicated to the study of carbon and its compounds. Silicon is a metalloid, and it is important in the semiconductor industry. It is used to make computer chips, solar cells, and other electronic devices. It is an essential component of rocks and sand. Germanium is a metalloid. It's used in infrared cameras, fiber optics, and solar cells. Tin metal is used as a coating for other metals to prevent corrosion, as in tin cans. The Oscar statue used to be an alloy of tin, antimony, and copper before 2016. Ever since 2016, it is an alloy of copper, tin, and trace amounts of other metals. Lead metal was historically used in plumbing, paints, and gasoline. However, due to its toxicity, its use has been significantly reduced. What are the family 15 elements, their properties and uses? Family 15 is the nitrogen family or the pnictogen family. In the absence of oxygen, the nitrogen in the air can induce choking, thus the name pnictogen. The elements are nitrogen, N, phosphorus, P, arsenic, As, antimony, Sb, and bismuth, Bi. They all have 5 valence electrons. They tend to gain 3 electrons in chemical bonds and become 3 minus ions. Nitrogen is a nonmetal, and it is the most abundant element in the atmosphere. It's used in fertilizers. The boiling point of nitrogen is negative 196 degrees Celsius. So cryogenic nitrogen can be used to make liquid nitrogen ice cream. Phosphorus is a nonmetal. It was discovered by Henry Moseley, a German alchemist, who extracted phosphorus from gallons of urine in 1669. It is the second most abundant mineral in our body and is stored in our bones and teeth. It's used in matches and fertilizers. Arsenic is a metalloid. It was used in pesticides, but due to its toxicity, its use has been significantly phased out. It's used in the semiconductor industry. Antimony is a metalloid. It's used in flame retardants. Bismuth, a metal, is used in pharmaceuticals and cosmetics. What are the family 16 elements, their properties and uses? Family 16 is the oxygen family or the chalcogens. Chalcogen means ore forming in Greek, since compounds of this family are found in ores. Oxygen, O, sulfur, S, selenium, Se, tellurium, Te, and polonium, Po, are part of this family. They have 6 valence electrons. They tend to gain 2 electrons and become 2 minus ions in chemical bonds. Oxygen, a nonmetal, is essential for respiration. Sulfur, a nonmetal, which is used in fertilizers, matches, lead-acid batteries, and vulcanization of rubber. Selenium is a nonmetal. It's a trace mineral needed for proper thyroid functioning, strong immune system, and DNA synthesis. Brazil nuts contain selenium. It's used in photocells, glass production, and anti-dandruff shampoo. Tellurium is a metalloid. It is in solar panels and color ceramics. Tellurium exposure can create a pungent garlic breath. Polonium was discovered by Marie Curie, 1867 to 1934. She named it after her home country, Poland. It's used as a static eliminator and as an energy source. Polonium-210 is highly poisonous. What are the family 17 elements, their properties and uses? Family 17 is the halogen family. Halogen means salt forming in Greek. The halogens are nonmetals and they form salts when they react with metals. Fluorine, F, chlorine, Cl, bromine, Br, iodine, I, and astatine, At, are members of this family. They have 7 valence electrons. They tend to gain an electron and become 1 minus ions in chemical bonds. Halogens are the most reactive nonmetals in the periodic table. When sodium reacts with chlorine, it forms sodium chloride. 2Na plus Cl2 gives 2NaCl plus heat energy. This is a highly exothermic reaction, releasing heat energy and a brilliant light. The reactivity decreases down the group as the atomic size increases. Fluorine has the highest electronegativity, which is the highest ability to attract electrons in a chemical bond amongst all elements. Fluorine is used in toothpaste and water fluoridation. Chlorine is used to disinfect water and it is present in household cleaning products. Bromine is used in flame retardants and pesticides. It is the only liquid nonmetal. Iodine is used in antiseptics and is needed for healthy thyroid functioning. Astatine is one of the rarest elements and it is radioactive with a short half-life. What are the family 18 elements, their properties and uses? Family 18 is a noble gas family. Helium He, neon Ne, argon Ar, krypton Kr, xenon Xe, and radon Rn are part of this family. They have 8 valence electrons. Since their valence shell is filled, they are stable and unreactive. Hence the name noble gases. Helium is used in MRI machines and balloons. Neon is used in neon signs. Argon is used in welding and lighting. Krypton is used in fluorescent lamps and lasers. Xenon is used in headlights. Radon is radioactive. Radon exposure causes lung cancer. What are the family's 3 through 12 elements, their properties and uses? Transition metals are a group of metallic elements found in the center of the periodic table, groups 3 through 12. They form stable ions with various oxidation states, and they also form colored compounds. Iron Fe is used in the construction of buildings and bridges. It is essential for healthy red blood cells. Copper Cu is used in electrical wiring and plumbing systems. Titanium Ti is used in aerospace, medical implants, and sporting equipment. Gold Au is used in jewelry, electronics, and currency. Platinum Pt is used in catalytic converters to reduce harmful emissions from vehicles. Tungsten W has high melting point, so is used in light bulb filaments and electrical contacts. Mercury Hg is a toxic metal, which is a liquid at room temperature. It's used in thermometers and barometers. What are the inner transition metals, their properties and uses? Inner transition metals, also known as lanthanides, elements 57 to 71, and actinides, elements 89 to 103, are located at the bottom of the periodic table. Lanthanides are part of period 6. They are silvery metals with high melting and boiling points. Actinides are part of period 7 and are radioactive. Neodymium Nd is a lanthanide. It is essential for the production of high-strength magnets. Uranium U is an actinide. It is used as a fuel in nuclear reactors and in nuclear weapons. Americium Am is an actinide. It is used in smoke detectors. Challenge questions. Question 1. How did Mendeleev organize his periodic table? In increasing order of atomic mass. Number 2. How is the modern periodic table organized? In increasing order of atomic number. Number 3. Why did Mendeleev leave gaps in his periodic table? Mendeleev left gaps for elements that had not yet been discovered. He also predicted the properties of these undiscovered elements based on their location in the periodic table. 4. How many valence electrons do the alkaline earth metals have? 2 valence electrons. Number 5. How many valence electrons do the halogen family of elements have? 7 valence electrons. Number 6. Which elements were discovered by Marie Curie? Radium and polonium. Number 7. What is special about the family 18 elements? They have a filled valence shell, which makes them stable and unreactive. Number 8. Which element has the highest electronegativity? Fluorine. Number 9. Which element has the lowest electronegativity? Francium. Number 10. Which element is the only liquid nonmetal? Bromine. Number 11. Name 2 liquid metals. Mercury and gallium. And number 12, which element was discovered by Marguerite Perry? Francium. There you have it. Mendeleev, Mosley, the element families, and the elements' roles in the world around us. Please subscribe, like, and share for more educational content. Happy learning! Thank you.